I'm Elizabeth Page. I'm Sales Director focused on the U.S. regional market. So I personally wanted to jump on here and welcome you to our webinar today, and thank you for being here. Just to put this in context a little bit, as many of you are aware, in late October 2017, the merger between Genband and Sonus Networks was completed, creating Ribbon Communications. And as Lance mentioned, we're focused on real-time communications and serving our customers and driving the industry forward with you. So after speaking to many of our customers after the merger, it was clear that there was interest in learning more about NFV and virtualization. You know, what is it? What is it not? So we reached out to Dan's team to create a webinar series to answer that need. Today's meeting and today's webinar and the following webinar on May 9th is the result of us taking your request and putting together a package to help inform you more about NFV. So please ask lots of questions today so we can ensure we're answering those questions that you have. And also it'll help feed some of the details in our next webinar on May 9th as well. So thank you again for being here. Dan, thank you for pulling this package together and leading the webinar today. I'm going to hand it over to you now.
Thanks, Elizabeth. Thanks, Lance. Welcome everybody to the series. As we've just said, this is the first of our two-part series. And so as you can see here, we have a pretty full agenda. And what I'm going to do, basically, as Elizabeth also pointed out, is provide some background and some clarity with respect to the evolution of telco networks to network function virtualization, and ultimately tell you how you can deploy session border controllers in a cloud environment. So with that, let's just go ahead and jump right into this. For many of you, I presume you were like me when I started looking at this subject a while back. That is, I was a bit confused by all the terms and I wasn't sure how it all fit together. For that reason, I really want to start with a definition of terms. I will be referencing these terms as I go through the webinar, so this is kind of important. It kind of sets the stage. So let's start with a hardware appliance. Nothing new here. This is application software running on typically proprietary hardware and typically with a fixed set of scaling that goes with whatever that appliance is capable of providing. Virtualization. Application software running on a commercial off-the-shelf platform, typically an Intel-based x86 server. It's not optimized or designed for a cloud deployment model. What it is it's a virtual version of what was running on that proprietary hardware. Network function virtualization started as a ETSI-defined framework, so a standards body out of Europe, and worked with many players in the industry and has driven an industry adoption using open source implementations. I'll talk more about that as we go forward. What NFV is that you have now application software as virtual instances called virtual network functions, VNFs, that can be orchestrated for many things, primarily starting with on-demand scaling, but there's lots of other things we'll talk about. And that's still not truly optimized for the cloud, although it runs in the cloud in most environments. Truly, the end game here is to be a cloud-native design. So this is taking things like adopting a microservices model. Again, I'll explain that more later. But being able to take that virtual network function and break it into its components, which allows people like us to provide our customers systems that have focus on individual focus on performance, on scale, on reliability, on deployment flexibility. Basically, we're creating a framework that enables our customers to do whatever they want with that application software. In this case, we'll be primarily talking about an SBC. And the application's designed to take advantage of the cloud attributes. So all of this will make a lot more sense, I hope, as we go through this, but keep this in mind as we go, as I talk terms. But before I do that, I want to give you a little bit of background on the marketplace. And so I want to start here with this first quote from Rajesh Ghai, who's the research director of carrier network infrastructure at IDC, a leading market research firm. So from their market research report in December of 2017, Rajesh made this point that there's a strong business case that exists for network function virtualization at the network edge. The point that is really important here is, and what I've highlighted is, This market research firm looks at the market, looks at the dynamics, looks at the future revenue, and says, this is real. There's a business case. People should be doing this. Now, what's more important is the second quote, where he says, while there's short-term business benefits in the form of lower acquisition costs, the long-term business case truly rests on the advantages that accrue from simplicity, flexibility, and agility for being able to deploy a service or network service. In this case, as we'll come back to, that network service is a session border controller function. So what I think I really want people to understand right at the get-go is this isn't just hey, there's a technology looking for a use case. This actually has valid business case reasons. We'll talk about them later as we go through this. It's happening now, and it's happening because it makes business sense for operators to be moving to NFV. So how big is this market? I mean, what's really happening out there? So here's some information from a different market research firm called IHS Market, and they track all sorts of things in the telecom industry, and for my particular purpose, I pulled this information out of their market research report from November last year. So VNF software is a big market. By the end of 2021, they're predicting it's going to be a $15.5 billion market. Now, that does not include VNF services associated with implementing VNF. It doesn't include hardware, because there's still hardware that's needed in data centers to do this. This is just services. Just software. So as you can see by the many colors on this bar chart, they've broken down VNF into multiple categories. One of their categories, as you can see, is titled IMS, SBC, and DSC, and that's actually the top box on each of the vertical bars. So when I look in detail at their numbers, that top section, IMS, SBC, and DSC, is going to grow at approximately 25% compound annual growth rate between now and the end of 2021. What's important here is that the market 2 to 4 years ago was still in very early stages, but since last year it's taken a significant uptick. And what you're going to see, and I'll show you in the next slide, is it's not only taking the uptick, but there's a real transformation taking place between deploying physical and virtual SBCs, which would be a subset of this gray category here. So I went back and I looked again at IHS market details, and we pulled out just this information of virtual SBCs as a percent of overall SBC revenue. The green represents physical appliances, the gray represents virtual network functions or software only. And what you can see is there was a big, even though the total market revenue dropped from 16 to 17, the percentage that was virtual, the gray bar opposed to the green, took a huge jump. And what you'll see going forward from this year, 2018 through 2022, at the end of their period, is that they're looking at a growth in the virtual versions of a session border controller from 40% this year to 76% by 2022. So if you look at this information and you trust that these guys have a reasonable view on the future of the marketplace, they're basically saying, if you're not already looking at buying virtual SBCs, you should be, because that's where the market's headed. So the premise of, again, as I said, there's a business case for this, there's a market growth to this. These data points are all lining up to say, if you're not already thinking about this, you probably should be thinking about it. If you are thinking about it, how do you move forward so you make sure you're successful? So answering part of that question is, what's the real progression of how you would implement a network service, right? So we're going to start with hardware appliances, right? We've seen that the market's research is bullish on moving to virtual, but let's recognize we have plenty of existing appliance-based solutions out there. Nothing wrong with being there, but the market is moving. So again, it's moving to virtualization. So we take that single software instance that ran on proprietary hardware. Now we run a single virtual software instance on a commercial off-the-shelf platform. So that's actually already been happening. Matter of fact, it's been happening for years. This isn't new. People have already been deploying virtual applications running on software in data centers for a while. But the next step, the one that we're really going to talk about and provide hopefully some background and education on, is network function virtualization as the next step. That's where you truly can begin to take advantage of operational efficiency and capital expense savings the NFV can deliver. So the market, as indicated by the market research firms, have already started to buy virtual SBCs. Many of those are now being implemented, as we are, as network function virtualization, which allows orchestration of these virtual software instances on an open platform. Again, I'll get a bit more into the details of what that means. But really, as I said, the next step is to move to a session border controller, or any application for that matter that you want a network service that you want to put into a virtual environment, and move to something that's cloud native. So it can be orchestrated and have multiple of these virtual network functions that are broken down into its component pieces and delivers some of that flexibility and efficiency and performance that are individually based on individual functions. And I'll explain why that's important as we go through this. So as we talk about this, as I talk about this, you know, there's a path that we've seen. We've seen this path with our customers. We've seen this path in discussions. But the real point I want to bring out is you can actually take advantage of that learning curve, the advantage of the learning curve we've had in dealing with customers, the advantage of what people have learned and told us as they've worked through these, certainly the advantage of what the industry's learned as it's done, you know, multiple of these initiatives and share them at industry forums and conferences. You can move ahead on the learning curve. You don't necessarily have to go through that path. You can jump onto the network function virtualization bandwagon today. Won't stop you from going through the virtualization over to NFV and all that. It depends where you are as a company, where you are with your plans and how you are ready to move forward. But I think it's important to understand that things have been out there for several years now. The market's taken an uptick. Take advantage of that and jump ahead. One last slide I want to show on this whole VNF and what the market looks like and how people are doing stuff is a deployment model. As I said, you know, things were a little confusing when I started. What does this mean? Where do I put these VNFs, the software running on a server somewhere? Well, starting on the far left, you can put that software in a service provider's data center, in a centralized data center. You can put it in a data center that might be out at the edge of your network if you've got more than one data center. You can actually deploy virtual network functions on servers running on customer premise. And that's getting a lot of attention in the industry about what are the functions that run best out of the customer premise and why, which ones do I want to run at the edge. Maybe I just have one centralized data center. Okay, that's fine. The real key, though, is that box in the middle titled VNF Controller Orchestrator. And again, the source of this graphic is from IDC, so they use these generic terms. But that VNF Controller Orchestrator, the thing that's going to manage the life cycle of these VNFs is centralized. And you get efficiencies by centralizing the management control regardless of where the software is deployed. So ultimately, the decision for where to place a specific VNF will depend on the application use case, the kind of infrastructure you have, whether it's what its readiness is, what the aggregate traffic conditions are, your technical knowledge, your deployment comfort levels. There's a lot of things that go into this. It's not necessarily a simple subject, but as I said at the beginning, and I think what Elizabeth says, we've got some knowledge here. We've been doing this for several years now. We have an idea of things that work and things that are easier and things that are harder. So with that, what I want to do is turn it back over to Lance for a minute, and we'll run a poll question to find out where are you in your NFV deployment plans.
Thanks, Dan. Yeah, so you should see that poll question pop up on your screen there. Just trying to get a gauge of where you may be in your NFV deployment plan. So you can just select one of the options there, deployed, implementing this year, perhaps you're in the testing phase and looking to deploy within a year, or maybe just planning for a couple years down the road, or maybe you don't have any plans at all right now for NFV. So just take a minute and look at that poll question. We'd appreciate your feedback. I think this is a good time too to remind everyone to be sure to ask us your questions. We do have experts standing by ready to help. And if you see a chat bubble icon blinking on the right side of your screen, that's a message that we've sent you as well. So be sure to check for that. So looks like some responses are coming in, Dan. If you take a look over there, you can see those, and we'll share these with the audience in a moment. But Dan, any thoughts on some of the data that you see rolling in?
Yeah, let's go ahead and share that. And then
Okay.
actually, it looks like a couple more people are chiming in.
Yeah, we got about 63% have voted, so maybe we'll just give it another 10, 20 seconds here. Let a couple more pop in, and then we'll share this data back with the audience.
So this is good stuff. I'll definitely have a couple observations to make as we go forward here.
Okay, I'm going to close the poll. Thank you guys for participating. I'm going to go ahead and close that, and we'll show this on your screen in just a moment. There you go, Dan.
All right, perfect. So running through this real quick, 8% have some VNF deployed. Nobody said they were implementing this year. 8% are looking at testing deployed within a year, and then a big jump up to 31% people in planning and a whole bunch of people who don't yet have plans. That is not a surprise. So let's talk about that for a minute, and then I'll move on. You know, as I said, things have been, the ETSI framework really came about 4 or 5 years ago. A lot of people talked about it. A lot of carriers said what they wanted. A lot of vendors weren't sure what that meant. Vendors had to obviously go through development cycles and get into proof of concepts and things. And as you saw in some of those earlier market slides, some of the purchases and things have been moving forward in a virtual environment. Now, we'll go back again to that progression of implementation and the definition tables. A virtual, again, I'll use session border controller. A virtual session border controller is available today from us. An NFV version of that is available. And again, we can point to some of the cloud native designs we've done. But it's not about us. It's about the readiness of the customer base and saying, I'm ready to start this. So I'm going to venture to say that there's a fair number of people in this audience who have applications running in virtual machine environments in data centers today, but they're probably not this application, right? They're not this network function. Maybe it's routers. Maybe it's some other function that handles typical data traffic. What we've seen in our customer base is people going, hey, I can adopt and take advantage of the same things that other applications are doing, but now do it in this voice over IP, real-time communications domain, and functions like session border controllers. So for the small number of people who've deployed and are testing, great. For those who are planning, hopefully I should be able to tell you and answer a bunch of your questions as you're going through your planning efforts. And for those who haven't started yet, maybe get you engaged and see how we can move those yardsticks forward. So with that, I'm going to go back to some of the basics of the webinar and say, if you're going to move forward, when you're moving forward, as you're planning this, wait a minute, I'm not sure what's really true and not true out there. I hear lots of stories. I need to kind of think through this. What I want to spend some time on now in the webinar is let's talk about 5 cloud myths to avoid for session border controllers and ultimately for success for real-time communications in the cloud. So here are the 5 myths. I'm going to walk through these, right? So each of these is a mythical creature. There's meaning behind that creature itself. I'll go through and explain that. So the cloud optimized kitsune. This is a mythical Japanese fox who's a trickster. And he'll make you think things that just aren't true. So that myth is virtualization equals a cloud native design. And that's not really true. And we'll show you why, and we'll tell you what some of those benefits are. The next one is, if I move my real-time communications to the cloud, it really won't be secure, right? That's the threat kraken, this huge octopus that's going to unleash monstrous security attacks. And again, we can show you how that's not true. We can avoid that myth. The next one is the scalable performance unicorn, where achieving performance at scale is just an illusion. It won't happen in the cloud. My appliance, I'm comfortable that I know how much performance I get. And again, we can show you how that's possible. And then 2 complementary myths. One, the load balancing atlas, and the second, the inherent redundancy Cerberus. So the load balancing atlas should be able to hold up the weight of the world, solving everything. And the Cerberus is a guardian, a protector. And so the relationship here is that redundancy and load balancing are natural in the cloud. They exist as functions I can take advantage of. And again, the myth is, yes, they're there, but they're not really optimized for most applications that we're interested in this domain, real-time communications. So we'll go through some of that. We'll talk about some of the things that again, ways to avoid these myths and ultimately be successful. So with that, let's get into some of these details. So we know firsthand, and I'm saying me personally, as well as, Ribbon Communications, that virtualization has value, moving to NFV has more value, and ultimately getting to a cloud-native design has the most value. When we've looked at this and we've had some conversations with our customers, what we recognize is that being able to take advantage of the attributes of a cloud design, and more importantly, the reason why network function virtualization first came about, is really important. Having a virtualized SBC in this case is great, but there's more advantages you can take advantage of. And I think that's really the positioning that I think is important that people understand. So a cloud native design means taking advantage of orchestration. That means that I don't have to manually go in and build another one of these virtual instances, right? I can deliver automated on-demand scaling of these virtual network functions when I need them. And I take advantage of that through something called orchestration. So again, I'll show you some more on that later on. When those virtual network functions are turned up, they need to be runtime ready. Cloud native means automated efficiency. I don't do a lot of manual things. So I want that virtual network function, whatever it might be, in this case, again, we'll talk about session border control, to come up, be runtime ready. I want it to be able to handle traffic once it's instantiated. Cloud native means taking advantage of innovation for features that are solving important things in the cloud, important to you or customers for the reliability, the load balancing, the high availability, how media transcoding, all those things that are handled in the cloud. You want to be able to take advantage of that and look for innovation. And honestly, back on a physical appliance, that innovation is kind of stopped for a lot of things. But if you move things to the cloud, you now can take advantage of things that you couldn't do before. And finally, integration across a NFV infrastructure via a robust ecosystem. We believe, the industry believes, all of the open source implementation is all driven by the industry has to partner from the top level of orchestration down to the bottom level of the actual virtual resources, how it works, how they verify things, pre-qualifying things, coming out with solutions that work seamlessly across multiple cloud infrastructures, even at some point seamlessly between carriers and how things work. All of that is being driven by a very robust ecosystem that didn't really exist days before, years before, when people were just buying another piece of hardware and putting it in place. There's good reasons to take advantage of that. The next one, real-time communications won't be secure, this threat kraken. So I will be the first to tell people that yes, while moving applications to the cloud does come with some security concerns, and certainly it's been the focus of plenty of news over the past several years, one thing I can say with respect to real-time communications is we already know how to do real-time communication security. We know how to do things because that's what session border controllers were designed to do. So now how do we take that design and those implementations and move them into the cloud, right? How do we ensure that applications, network firewalls, right? Intrusion detection systems that don't truly understand voice applications and voice over IP, but SBCs do, right? We're stateful aware at layer 7. We understand the subscriber, the end user. We understand the server they're trying to reach, the application they're trying to use for unified communications. We know how to dynamically open and close ports to prevent exposure and basically leaving open a port as an attack vector for someone, right? So as we take that information and move it into the cloud, right, we recognized, and our customers certainly told us, right, you need to be able to bring that into the cloud. You need to be able to give me, though, the same security I would have had on a traditional appliance. Oh, and by the way, you need to do a better job of security because now I'm in the cloud and I want you to be able to prevent people from hacking in the cloud and using this real-time communications as a pathway into the network, right? So that's what we're doing. That's what we're all about. That's where we're driving toward making session border controllers becoming an important part of the whole migration to security orchestration in the cloud, right? It's a side topic. It's an important topic. There's other initiatives in Ribbon that are taking us into this space, and we'd be happy to talk more about that if people have concerns about moving real-time communications into the cloud and moving SBCs in there as well. Achieving performance at scale, or the fear of not being able to achieve performance at scale. So again, first-hand knowledge from us with our customers is it is absolutely possible to drive performance across multiple vectors and to achieve the ability to scale VNFs. I mentioned microservices before and the ability to break a virtual network function, an SBC VNF, into its subcomponents, right? Signaling, media, transcoding. We've done this. We actually have this deployed. What that allows us to do and what allows our customers to take advantage of is that the scaling for virtual functions now can scale independently for signaling than it does for media than it does for transcoding. You may have an application of an SBC that has very low transcoding requirements. Well, then you don't need to scale up resources to do that beyond what you need in an individual scenario. Again, signaling scales on very different functions than media does. So, the ability to scale independently for different components of a session border controller, critical to being able to achieve that performance at scale. Performance by feature independence. I want to be able to either use a virtual instance to do something specific, or I want to be able to ensure that when I implement that in a cloud-native design, I can have features turned on that don't impact other functions. As an example, being able to turn on encryption across the entire traffic base, but not impacting how many concurrent media sessions I can handle. Again, really important functionality that can be delivered in a virtual environment. Finally, the other one that we found is increasingly important is being able to apply technology choices to an individual SBC function or an individual VNF. So there's reasons to use different technology to take advantage of different functions. The one I can give you an example for is we've done a lot of innovation around using graphical processing units to take advantage of massive parallel processing, which is a big differentiator in how we do transcoding than perhaps using it on computing CPUs, on compute processing units. Doesn't mean they don't work. They both work. But again, it's what's driving your decisions about how you want to implement. As I said earlier on the deployment model, right, where you deploy it has lots of factors. Which technology choices you use tie into some of that as well. Again, I think it's important for people to understand the advantage of this cloud-native design, the advantage of what can be done and how to debunk these myths, right, is that there's people who are looking at this and designing things to solve problems before you encounter them in your networks. Okay, so I talked about these two complementary VNFs, the load balancing Atlas and the redundancy, inherent redundancy Cerberus. So load balancing Atlas, in theory, right, this powerful denzine of the cloud who should be able to handle traffic and load balance across these virtual resources that you're deploying. But the reality is it doesn't really do well for real-time communications, and I'll explain that in a minute. And then the redundancy Cerberus, right, is a guardian who should be reliable. So where's your reliability in the cloud? What are those failover mechanisms that need to work? And so again, what we found and some of the innovation we've done is around solving problems that are very specific to real-time communications in the cloud. So most of the load balancing solutions that exist in the cloud for typical web-based data applications don't really work or are insufficient for real-time communications. Having stateful knowledge of the real-time sessions across multiple VNFs so you know when to load balance, and for that matter, when to add another virtual network function to pick up increased load, or get rid of a virtual function because now my traffic load's going back down, I don't need as much virtual resources allocated. As those virtual resources are both instantiated and removed, I need to optimize the load across the number of virtual resources. We've kind of figured out some really important ways of doing that. Reliability and failover mechanisms. There's no ambiguity here. I need it as good or better than what I get in my hardware appliances. I need it to meet the time frames, the low latency time frames. I need it to be able to handle calls. I need to not lose calls. I need it to work now that I'm running across these multiple virtual instances, right? It's complicated, and we've spent a lot of time making sure that we can meet the obligations, matter of fact, meet the hard requirements that our customers expect. And so if you look at load balancing and reliability and say, well, those are already things that can take place in the cloud, and they do, the real issue here is, do they work for RTC the way they need to? And in our case, we've said, not really, but we've done some innovation to solve some of those problems. And for people who are on now, that'll be a lot of the topic of the second webinar, where I'll go into some of those innovations and kind of explain the problems we saw and how we solved them. Okay, so we have these myths that may have prevented us from moving forward, or confusions that we might have had. We have some reality that goes with it. But then what, right? Where's our criteria? What's the criteria for successfully moving real-time communications into the cloud? So these 4 criteria, right, are plain and simple. If you don't hit them, you're not going to be successful. I need, if I'm going to put real-time communications in the cloud, to increase my service velocity and my customer responsiveness. I need efficient use of virtual network resources. I need it to be as secure and reliable as traditional hardware. And I want to be able to have increased deployment flexibility choices with operational cost savings. So if I can't achieve those, maybe I shouldn't be moving to the cloud. Well, my response is, yes, those are all achievable. People are doing that today. But keeping in mind that those are the criteria for successful real-time communications in the cloud, right? What are the attributes of this cloud-native SBC that are needed, right, to get you there? So I've talked about these as we just talked through some of the myths, but I've kind of put them all in one place so we can kind of look at them in aggregate, right? Service orchestration to instantiate runtime-ready virtual network functions, right? Integrated analytics to enable on-demand VNF instantiation and to align the virtual resources with the actual traffic, right? Innovation for redundancy and load balancing. Performance at scale with technology choices. Security equivalence for what's available today, plus the new things you need to do because now you're in the cloud. And again, an integrated ecosystem and the ability to validate multi-vendor solutions, right? Those are things that we see a cloud-native SBC having to do to participate in the success of real-time communications in the cloud. So let's again take that and again put things together. So instantiating a virtual SBC, the SBC VNFs, and doing it securely for RTC traffic in the cloud, being able to do that in a matter of minutes clearly increases your service velocity and your customer responsiveness, right? No longer are you waiting to get a hardware device implemented, takes a long time. Maybe not even doing it with a virtual device. So I need to download software, I need to put it on a virtual machine, I need to turn it up, I need to run some test calls, right? You've already got, in this case, virtual network functions running. Another one is instantiated for more traffic, or if one of those goes down, you can instantiate another one for healing. It's the ability to be very responsive to your customer needs without all the hard work that used to go into other options. On-demand scaling based on analytics to optimize that investment in your VNF resources. That's a clear way to deliver efficient use of those virtual network resources. So a virtual network function is turned up on a virtual machine. There's associated hardware, there's storage for the processors, there's hardware for storage, there's network connectivity costs that run across your applications in your data center. All of those have to be used, but they have to be optimized for how they're used. Achieving performance and security without hardware lock-in. Again, delivering equivalency to appliance solutions for the application, but doing it in a much more flexible and dynamic manner. And finally, taking advantage of riding the innovation curve for telecommunications in the cloud. We're doing a lot of work. The industry as a whole is doing a lot of work. There's a lot of work going on in open source forums and communications between vendors and vendors and carriers and operators and between operators for that matter on how things should work. And this innovation allows us to drive the benefits for you, for new technology choices, for delivering reliability, for reducing your operations costs by gaining efficiencies. All of that is very possible. It's very possible today. So with that, I'm going to kind of leave this simple recommendation, and I think this is pretty straightforward. Starting at the top, align your real-time communications business drivers with your cloud network priorities, right? Understand where that virtual SBC reality will be, how it will enable your real-time communications. Look for those solutions that have the cloud-native attributes that are going to be important, and then go ahead. And as you deploy them, you'll be enabling the real-time communications in the cloud and your success with real-time communications. So with that, I'm going to leave this slide up for more information. We've already mentioned it. We'll mention again. The second webinar in this series is May 9th at 11 a.m. Eastern. Remember, you have a chance to win if you attend both webinars in a drawing for an Amazon Echo. There's a couple of links here, which will take you to our website for more information. As Lance had said earlier, we do have a white paper that you can download, Understanding NFV, its benefits and applications. So with that, I'm going to take a look at some questions. See what we've got. Hold on, it's going to take me a moment to pull those up. Let's see. I'm trying to see how I can. My apologies on this. Lance, how do I make this question screen bigger?
You should just be able to expand that out by using that little expand icon next to the X. There was, if you're not seeing that, I can read one of them off to you. I do see a couple that came in and I think are good to address now, if you just want me to read a few to you.
Yeah, unfortunately, I apologize. The screen is cut off on my
problems. So
yeah, go ahead.
One of the first questions was that you mentioned cloud native design and it takes advantage of microservices. Can you give more detail about that?
Sure. And then, like I said, we'll cover that in more detail on the second webinar. Microservices, traditional software on a hardware appliance is developed with a monolithic design. That doesn't mean that there aren't multiple functions and subroutines and things that are inside the development. But when you get a software load for a hardware appliance, you get the load, you get everything in it. It doesn't necessarily mean you're going to implement every feature that's available, but you get the software load as is. There's no components broken out. You may have features that you have configured to turn on or not use, but the software is designed as an entity, as a monolithic entity. Microservices breaks that apart. It says, I'm going to build a software design with many functions interworking. Those functions, have to be concise and consistent in their communications between them, but it allows me to take advantage of doing things with those functions in terms of if one function needs to be updated, I can update it individually. If one function runs better on different technology, I can run it on different technology, that kind of thing. So we'll talk more about that in the next webinar.
Okay. Another one that came in, the ability to scale on-demand elasticity. You mentioned that it was very important. Can you explain a little bit more why that's a very important aspect?
So traffic demands are not consistent. They will vary. Taking advantage of being able to dynamically allocate virtual resources that's aligned with that traffic variances or being elastic, that's where that term comes from, drives the efficiency of the implementation. And so, again, it's not the only reason you want on-demand scaling. As I said earlier, you may have multiple instances of a virtual network function running, and one of them goes down for some reason. You can bring another instance up very quickly, right? It's dynamic, on demand. I can recognize by looking at key performance indicators that I've reached a traffic threshold on a virtual instance. I need to instantiate another one and then load balance across them. So it's that ability to scale on demand and up or down that becomes really important to maximizing the efficiency of this whole microservices and this whole NFV model.
Okay. Another question that came in was about sort of the service differences. So suppose they have a virtualized SBC, but it's not orchestrated. What's the differences in services?
So I can get into that a bit here. I'll touch on that in the next webinar as well. Service orchestration. So let me start with VNF lifecycle management. We'll keep it very simple there. Virtual network functions get instantiated. They have a configuration that has to be built. So when they're instantiated, they come up, as I said earlier, runtime ready. They have a life cycle. There's monitoring of them. There's health management of a VNF. Ultimately, a virtual network function may be running. You may no longer need it, so you tear it down or you no longer have it instantiated. That life cycle management is very important to the VNF itself, but one VNF may not make a service. So if you have session border controllers and you have policy servers, so policy decisions are being made about where to route traffic that's then being handled by a session border controller. The ability to do service orchestration or service chaining. So I see traffic changes. I have policy changes I make. I may do some least cost routing and move traffic somewhere else. Now those policy decisions are being made and traffic's running over different virtual network resources perhaps, or I need traffic to be balanced differently. So service chaining allows me at the service orchestration layer to say, oh, I need more of this, then I'm also going to need more of that, then I'm going to need more of this third function, and I'm going to put them together to provide a set of services to an end customer, typically an enterprise. So service orchestration is that next layer up. And again, I didn't provide here a architectural model of that ETSI framework, but like I said, I will cover that in the next webinar.
Great. Thanks for that. We just have two more, then we'll wrap up. You talked about the NFV ecosystem that we have. Can you just mention some of the vendors that we're working with?
Yeah, so again, it's a bit visual for people because that I don't have a diagram, and I apologize the more I think about it. The virtual network function, imagine it's sitting in the middle of an architecture. Down below it is the virtual network function infrastructure, which is the hardware runs on the servers, the network processors, the memory allocation, that kind of infrastructure. And then above it is the VNF lifecycle management and service orchestration. So on the downward side, we're working with people like Red Hat and Wind River and HP and people providing OpenStack implementations. And again, I'll talk more about this when we go into the next webinar. And on the top side up, we're talking with people like, again, HP and Rift.io and Juniper and multiple people who have service orchestration and functions in that area for lifecycle management. So on our website, if you go to that link that says VNFs, there's information about our ecosystem and who all our partners are. There's actually under our partners tab at the top, it lists all of our NFV partners. So if there's somebody you may be thinking about and someone you want to talk to, maybe we've already done that, we can help broker that.
Okay, and the last question, and when we answer this one, Dan, you can just add any final thoughts you might have. You can throw it back to me. But the last question we have was talking about the performance of the virtual resources. So the question is, can the performance of a virtual resource really be equal or even better than an appliance?
Yes, and we've got some numbers on some analysis we've done. We can show the kind of numbers that can be achieved. Absolutely, the answer is yes. And again, it's kind of hard for me to just throw numbers randomly out there. But yes, certainly we have implementations, and the industry as a whole has done a lot of good work in being able to achieve that. Some of that was innovation on our part, moving to new technologies. Some of it, I mentioned OpenStack, which is the OpenStack is the implementation that all this software runs on. And for example, we've looked at that and said, well, there's configuration parameters in OpenStack, and if we configure them this way, we will optimize our particular application for real-time communications. And we've brought some of that back into these open source forums and stuff. So yes, we figured it out, and we have some information on our website with more information on white papers. And again, I will be talking about that in more detail on the second webinar. So with that, I want to thank everyone for attendance and attention, and we look forward to talking to you again in 2 weeks.
Thanks, Dan. Yeah, thank everyone for attending. Certainly, just wanted to mention real quick, again, the next webinar, Achieve Real-Time Communications Cloud Reality with a Cloud Native SBC, is on May 9th at 11 a.m. All of you who can hear my voice who are attending this webinar are already registered for that webinar. So you will be getting a reminder as that date approaches. In addition, if you do attend that webinar as well, you will be entered for your chance to win that Amazon Echo, so be sure to show up on May 9th. We will be sending out an email later today following up with you, and so look for that coming in your inbox. Again, the link's in front of you there to find out more information, not only on BNF, also on the Cloud Native SBC. And again, that white paper can be accessed there as well, also by clicking that document icon. So thanks everyone for your time. There were a few questions that we didn't quite get to, so we will follow up with those people individually. Thanks for your time, and we will talk to you all on May 9th. Take care and have a great day.